over the next 30 minutes or so, we'll have a section for discussing R and how I've used it in the LANDFIRE realm. And in some ways, it's specific to vegetation departure. It's going to be a little bit more broader than that. So with that, I'm going to share my screen. I'm going to launch into a short PowerPoint. Then, well, you'll see where I'm going. All right, so a little bit of context about myself and R. Basically, I know enough about programming to put a pun in the title, and I was very proud of myself for that. But tell me that I need to go like implement a loop, or I would struggle. I would 2 hours on Google and Chat GPT later, I might have a loop going. Another way to think of it is that I'm not a programmer. I can play the song, but I don't know the theory, the scales, the chords, the arpeggios, whereas a programmer might know the theory, the chords, the scales, the arpeggios. And so my limit is that, folding in other code, explaining the details behind what's going on, I'm going to come up a little short. So with that, I'm going to show you what I've got, and hopefully it generates some conversation. So thumbs up, did you like the pun? All right, my goals, an absolute home run for me here would be if we generated some ideas about how to best share coding knowledge and code, or maybe even just no, we shouldn't do that. That would be amazing too, just to have a discussion around that would be great. I would love to brainstorm how we might, leverage the coding skills in the group or outside our group to help automate, speed up, and communicate analyses. Amy's discussion of succession classing was just kind of the tip of the iceberg about ways we might automate, reduce errors, and make our work more reproducible and transferable to others. And then also, I'm going to share some of my outputs in hopes that either, we can crowd shred my code or they inspire you to try something different and better. I also want to show you this R LANDFIRE package that may be new to you and share that we have a Slack channel. I just wanted to quick answer a couple questions and then reground us on the flowchart. The flowchart again, why code? If you haven't coded before, here's why I think code in my mind. To speed things up is a hypothesis. I put hypothesis there. I mean, here in the chat for how many people have struggled for 2 hours to figure out how to put a comma in a number in a ggplot axes label. Sometimes coding can be excruciating, but in the long run, it does speed things up. And to make our analysis reproducible, my story there is, getting a CSV file from someone, opening it up in Excel, and there's calculated columns, and I don't know, there's no formula or anything, and I'm supposed to check the calculations, believe the calculations, I don't know what's there. That's just probably an oversimplified example, but everything you do in code is there in the code. If you're, doing it well at all and doing it and not just in the console, maybe, and not saving it, that sort of thing. So, yeah. Then with the VDAT flowchart, okay, please ignore that arrow. I should have taken that arrow out. But what I'm going to talk about today is show you some examples where I do, make those charts similar to the one Lisa had with reference percent and current percent of succession classes, but also talk about some of the code I use to generate maps and summary charts of some of the inputs to share with people. All right, so we'll be talking about vegetation departure, but I put VDEP plus in my title because there'll be a few other data sets that we'll talk about. One thing that will happen a fair bit for us on the LANDFIRE team is someone will say, hey, Randy, can you help us summarize LANDFIRE data for our landscape? We like to quote a free sample of sorts. And by free, I don't mean monetary. I mean kind of time and collaboration effort, right? Our team is paid to help people use LANDFIRE data, but a free sample means that maybe they send us a shapefile of their area of interest. We do the processing, spit some things out, and the next steps require more collaboration, more detailed questions, that sort of thing, data review. So our team has done a lot of this through the years, and what I found is people like something on the web as opposed to a PowerPoint. You know, it's a pain to send a large PowerPoint to someone. It's getting easier. There's ways to compress, but we've started trying to deliver things on the web. So what happened here is that the Southern Rockies Fire Science Network wanted us to just generate some very basic summary maps and charts for their 5 subregions. So I'm going to show you a web report we put together for them as a way to show you how I put code together and talk about some of the background work here. This web report, which some of you may have seen, is built on Quarto files in RStudio. And it's, as you can see at the top, it's hosted on GitHub. So it's all free. The maps were made in QGIS, an open source GIS program. You'll notice that the author includes the Conservation Data Lab. That's a group I run of young professionals and students. So oftentimes they don't have the money or the interest in dealing with ArcGIS Pro or even Microsoft products. So they want to learn R and QGIS. So the area of this assessment would be the Southern Rockies subregion, highlighted here, a very simple leaflet map with the shapefile that they sent me and a base map. So I'm going to hop over to the Past tab. And as that pulls up, I'm going to scroll down and show you just what we did with the legend in the map. All right, so in R, what I did was I cropped and masked all the GIS data to the area of interest, the shapefile. And then I kind of built the attribute table, if you will, and then I winnowed down the attribute table to the top most prevalent biophysical settings and built what's called a color file for mapping in QGIS. It makes mapping categorical data in QGIS a lot easier, or maybe it just makes it possible if you have this color file. And then I need to winnow it down more. It's really hard to even distinguish 10 types. I think we're down to 8 types on this map. It's really hard to distinguish 8 types on a map. So I need to winnow it down even more. And we are trying to apply accessible color palettes. I've got a lot of room to improve there, but that is something I'm trying to do. Another thing that people want to know is about their historical disturbances. So I built this, it's kind of an interactive chart where you can go in and type in a biophysical setting. I'm going to go down to this one here, click that, and you get the annual acres of disturbance historically. I can never say that very well, by biophysical setting. So this is saying that, okay, for the Southern Rocky Mountain Ponderosa Pine Woodland in this ecoregion, there would have been roughly 150,000 acres of surface fire every year historically. And I don't have the tooltips turned on. It's a Plotly chart, and I just have not gone in to clean up the tooltips of the Plotly chart. If you know how to do that or be willing to help me work in Plotly, I would love some help. On the present tab, we have summaries of existing vegetation type data, cover, and height. And I'm going to jump down to the cover to show you a couple of things. Here's a cover map. And the first thing I'm going to tell you is that Sarah Hagen on our team has developed a much better color ramp to use with this. So this is not an accessible map. It's really hard to distinguish the shrub and herbaceous types. So that is a failing of this map for sure. And it's compounded by this chart, which I thought was kind of clever. You know, I have the colors lined up with the different categories, but I'm really looking forward to ingesting Sarah's new cover map symbology and rewriting all this code so that these charts and the maps are accessible. So thanks to Sarah for that. I just got that today, so I'm really looking forward to that. Then on this comparing tab, I wanted to highlight a couple of charts because there's something you might run into as you do vegetation departure. All right, mechanically on our flow chart, you see that you may have noticed that spatial combined for vegetation departure. Essentially what you need to do is for every pixel, you need the biophysical setting and you need the succession class. Those come in two different data sets. So you do a combine in the spatial analyst toolbox of ArcGIS Pro, or you code that in R. Again, so that each pixel has the biophysical setting, that ponderosa pine woodland, and the succession class, A, B, C, D, E, U, N, and so on. Right, so you can make those charts and get that. That's how you would get the current conditions. What people often think you are doing is combining LANDFIRE biophysical settings and LANDFIRE existing vegetation type. People often will think that is what you're doing. And it's for vegetation departure, that is not what you're doing. But for this chart, what I did was I did a combine of the biophysical settings in the EVT and R so that each pixel has the biophysical setting, and then on top of that, what it's mapped as today. There's some definite squirm factor in doing that. The data is not designed for that. The legends are kind of different. The methods are obviously very different. So what I've done is I have used the broadest groups possible, the broadest lumping, to do this work, because people do like to see this. That is, they like to see, you know, of the area that was mapped as conifer historically, how much is conifer today, right? So on the left are the past categories and on the right are the current. So most of what we mapped as conifer in the biophysical settings is still conifer today, though there is some conversion to ag, grassland, exotics. When you look at those two data sets, there's the whole accuracy discussion as well. But you can also circle and say, okay, what is grassland today? Where did it come from? With the LANDFIRE mapping, this is what we came up with. And so it hopefully triggers discussions about what's going on. Okay, so the hovering things is swaying me. Sorry, Amy. Hope there's not too much nausea there. Yeah, so
no,
we'll move
I
on.
was having feelings about your map, but you're getting me to come around to your side on this graph.
All right, thanks, Amy. All right, you know, it's a provocative one. Some people just can't stand it, and other people love it. Some people like a much more linear, like a Sankey diagram, where you have past on the left, current on the right, and you have bars that connect the two. Yeah, so this is like maybe like cilantro. People love it or hate it, or the band Rush, you know, it's like a love-hate kind of thing. All right, then scrolling down to what we've been talking about, and I'm going to zoom in here. These are the charts you've been seeing. This is where in R, I did that combine of the biophysical settings and the succession class data set to calculate how much of each succession class we have on the landscape today. Then I joined that to our reference conditions database to get the reference percentages. So as I mentioned, this is kind of a free sample, a teaser. So I do not have cool labels like Lisa did. I just have A, B, C, D, E. Alone, those are pretty meaningless, or maybe you would say absolutely meaningless. We see that there's, you know, an overrepresentation of this class C in the lodgepole pine forest, but we don't know what C is. So I do not have those labels. I've been talking to some of you about how to bring that in R. When I'm at my best, I take the time to literally type something up, you know, that splits the charts apart, and I might have something with species, height, and cover. There are ways to pull that out, but I end up typing it in sometimes. So that's a bit of a mess. So I'm going to go back down to this level, and I'm going to show you something else I've just started working on. All right, so as Lisa mentioned, the Forest Service has their hierarchy of terrestrial ecological unit inventory. TUI, I've been playing around with the idea of somebody being able to click onto an LTA and getting a report. And it's just very clunky right now, but you can click here and you get something. This is proof of concept to just see if I could do anything. It's using parameterized reporting. And so I was very proud to get this to work. Looking forward to adding to this for the Shawnee, and or just not, because my Forest Service folks have done it already. So that would be great as well. Another related thing I wanted to show you is work by a student named Mary Kelly. She is at Northern Michigan University, and she came to me, scroll down a little bit. She came to me wanting to learn about the forests in Western Oregon, and she also noted that the Biden-Harris administration had issued this executive order around old growth and mature forest. So I said, sure, that would be great. So what she did was she took data from map zone 2 to keep it simple. And she did, the GIS work largely in ArcGIS Pro, and then the coding work to make this website and the charts in R. And it's mostly for her fun. We are not trying to jump into the mature, old growth, late arguments, discussions, debates. We're not trying to do that. This is mostly for her learning, but it's been a great opportunity to discuss those problematic, I'll say, terms. And, one thing I wanted to show you was this chart, a couple of charts she came up with. One is this one that has the total acres of each biophysical setting, excuse me, in the area. And then the different colors indicate the different succession classes. So it was cool to see her come up with that. And then I'm going to hop down here. Sorry, Amy and others. I kind of like this chart. So this is changes in late succession classes, historical to roughly 2020. And it's not surprising to see that most of the biophysical settings show a great loss of the late succession classes. She also split it out by open and close, which is really interesting because there could be fire adapted ecosystems that would have been dominated by more open canopy late succession. So basically, she used the table that Amy references in the chat to split out those types. And so anyways, it was just super fun to work with her on this. So that's sort of my buffet, and I'll show you a little bit of the code in a minute, but I wanted to drill into work by Mark Buckner. He is a PhD student at Cornell University. And he has built this LANDFIRE package, and I'm just super impressed with his work. Basically, the idea is simply he wants to build an R package to bring data into R from LANDFIRE. So he's got a really nice tutorial here. And so I strongly encourage you to give this a go. Go through the tutorial. I'm going to scroll down, close your eyes. He basically shows us how all in R, we can go in and calculate the change in canopy cover. Oh, sorry. Whoops. Sorry. Close your eyes. Canopy cover using his package and R. So this is just a really basic vignette, but it's really effective in showing you how he works with LANDFIRE data in R. And I've had great luck with this package. So I wanted to just stop really quick and see if there's any questions or comments about all that before I show you a little bit of code. I could see that I might imagine a lot of us don't need to get LANDFIRE data for a specific area. We get the whole CONUS data sets if you're more of a regional analyst or something like that. But anyways, I'm going to show you a little bit of the code for this, and just let me know if it's making you nauseous. I thought you might want to see it, but let me know if it's just not useful. So some details going into the weeds. You'll see I've commented out the raster package. I think I've transferred all my code to the updated Terra package for dealing with raster data. Yeah, shout out to everyone who's done that. It was not that fun for me, but it's done now. So I read in this Soro shapefile, and I'll just show you again. That was the Southern Rockies. Same shapefile as before that I showed you on that website. Then you just run a small bit of code to get the area of interest, a rectangle or extent of that shapefile. Then you define some specific parameters for the download, right? So you list out your products that you want, and he provides a link to the table of LANDFIRE products and their official names. you give it a projection using the well-known ID number. So 5070 matches up with the native Landfire data sets. And then you define a resolution, and this is in meters, so 30 meters for me. It comes in as a zip file, so I just have it go to a temp file, and that there's a special folder I have set up where it goes directly there. When I first ran this, I couldn't find the zip file, so I had to learn about that temp file function to get that to work. And then you basically run the Landfire API function with these arguments, and there are many more that he's given us. And to get the biophysical setting and the succession class data with my internet connection at a university office, which I'm assuming is pretty fast, was under 2 minutes. So it worked pretty well. I unzipped those files to my data directory, and then I don't know the proper terminology, but basically the data sets, maybe it's a raster stack. Sarah and others, please correct me. I had the biophysical setting and the succession class in one TIFF file. I wanted to split those out. In my head, it was just easier to work with. I don't think that's the proper way, but that's what I did with this line of code. Then I cropped it and masked it to my area of interest because it comes in, of course, as a rectangle. I'm going to scroll down for a minute. I did this work to build an attribute table for my area of interest the way I know how as a non-programmer. Then Sarah Beyer I don't know, a while back, helped me develop this code where I could write the raster out with all the pieces I need to open it up in ArcGIS Pro. That was not trivial for me either. All right, so I'm going to scroll down here and show you the plot that I made. Whoops, no, I'm not, but I'm not going to make you watch me. Wow, embarrassing. I'm not going to make you watch me rerun all this, but I make a basic ggplot chart like you saw in the web report. And then that's basically it for my demo for you. I wanted to show you that it was possible to bring the data in using the R Landfire package and then do some manipulations with it and show you that code. And I'm happy to share any of the code or any of the concepts with you one-on-one or one in a group, however. But with that, I'm going to put these kind of starter questions in the chat because I'd really like to hear from you. And, you know, we might sick Jackie on you if needed. Azad, no, I do not have the raster package activated. At least I don't believe so. So, yeah, my first question to you, I guess even the precursor question, should we share code? Is there interest in out there for sharing code around using Landfire data, that sort of thing? Well, that's great. And that means to me that the next question is worth a bit of discussion. So in my kind of simple programming mind around this, it's like we could share code via the Slack channel or emails. We could set up a GitHub account and share data there, or we could, you know, build our own Landfire package or ask Mark if we can collaborate to add on to his. And there's probably other options. But what do folks think? Is it, you know, how big do we want to go here? Do we just want to share code and ideas via Slack channel, or do you guys even have like almost your own package that you're using in your world that, you know, is not on Git or CRAN yet?
Yeah, Randy, I'll jump in. I'm very interested in, I've downloaded and started to work through the vignette for the R Landfire package, but I'm not very far along with it. So, but yeah, I would like to definitely share code and contribute to the Slack channel. And I've been harvesting some of your code, making branches off of it, or pulling it just to look at ideas of how you've done things. And that's been very helpful to try to get my head around and to develop some of these examples for using TUI and Landfire data. So
You know, I have to note something I failed to mention, that, you know, folks from organizations such as GTAC, Zach might be here. I don't know if you're here or not. He sent me some code that does some of what my code does, but in like a tenth of the number of lines, you know, super elegant stuff. So people with more programming experience could make my code a lot more elegant, or probably have very elegant code. So I'm definitely, you know, open to sharing, because again, yeah, I'm not a programmer, so use all my code with caution. Any other thoughts on how to best share? You know, it sounds like I've got to vote maybe Darren on for the Slack channel to start. Would that be the best place for us to get going?
It's a good place to get together. I, I mean, a lot of the repositories, I mean, that's designed for branching and modifying codes. And you can, if you like improvements, you can join stuff back if people actually do work in a collaborative manner on a project. A little more complicated, but that's basically what GitHub was designed for.
Yeah. Does anyone know if the Forest Service can use Slack? Amy, great question, foundational question. But Darren, it does sound like GitHub is not a problem. So that might be something that we look into, is setting up kind of a LANDFIRE-ish GitHub account.
Yeah, I don't know. I mean, I just use my personal account. I'm not sure the restrictions on that, or I probably should, but that was one of the things we talked about is moving forward is I don't want to be hosting final products on my own GitHub site. And so trying to find a web-based platform to migrate some of these HTML outputs and graphs over under the umbrella of the Forest Service, working with either GTAC or others that have a lot more knowledge than I do on face fronting websites for that under the Forest Service.
All right, so just a shout out to Aaron's comment in the chat about enterprise GitHub. So I know, does it work like this? And the Nature Conservancy account, how I work is I have my own GitHub account that's my playground, and students do as well. And then when we've got something we want to lock down, we move it to the Nature Conservancy's GitHub account for longer term keeping. Is that kind of how you might operate, or do you just use the enterprise GitHub account from the beginning, you know, if you're going to follow the SOPs?
Yeah, so way that the Forest Service GitHub Enterprise one works is that you basically, whenever you get a license, you get your own page that you can do whatever you want. It could be private, it could be public, et cetera, et cetera. But then we have groups and for different teams that we maintain. So like EMC has one, the Mature and Old Growth Initiative, we have one. Then that way we can administrate them on our own and add different users to them, and then do kind of what we need to do from there. So you can kind of develop it on your own and have your own stuff, or like as part of that broader team.
Aaron, is it more for internal collaboration or external sharing of the information?
Yeah, there's some stuff that it gets kind of a little bit confusing on that. It depends on how you set up. There's rules and guidance on that. But
Okay.
it would be more, I think, usually internal is a lot easier on that. I think if there was going to be like a TNC LANDFIRE kind of a situation, it would just be something that you all would host through GitHub, and then we could just make comments to the code just like in any other GitHub from there.
Mm-hmm.
Yeah, we do have a TNC or Nature Conservancy GitHub account, and then we have not created our own organization within that, or sub-organization. That might be the way to go, to have a little bit of a firewall. So we're not adding to the dozens or hundreds of repos in the Nature Conservancy's GitHub account. But I think that would be a way to go. And then also, just as a matter of course, I will invite you all to our Slack to see if that will work for you. the invitation link will only, it'll last like 7 days or something like that. So Rick asked a great question, and I'll start the answer to this, but others please, add on to my answer. What I tell students is my starter answer to what is a GitHub is sort of like a Google Documents for code. It's way more sophisticated than that, once you get into it, but it's a place where you can host code. People can essentially comment on the code and accept or reject the code, sort of as Darren was mentioning. And also it's a place where you can serve out websites. For that chord diagram I made, it's essentially an HTML document, and you could serve that out. Like if I just wanted to send you a link to my chord diagram, that circular one, or an interactive map, I could host that on GitHub as well. So it's sort of like a Google Docs for code and a place to host web deliverables. So that would be my start at an answer on that. And great question. Thanks, Rick. Okay. So yeah, Sarah Beyer, thanks for your comment about S-classing to the LANDFIRE package. I think that Mark is very open to that sort of thing, and he's really good at keeping us, being active on it and updating it if I send him a bug or somebody sends him a bug. So I think he would really be keen to give that a go. He does pollinator research. So I don't know if there's a hook in there for him with pollination, but anyways, there might be.
Sounds like he's got other stuff going on too.
He does have other stuff going on, but yeah. All right, so let me just summarize and say it sounds like there is some interest in us sharing code, probably via a NatureServe GitHub account. And so we can make that'll be a multiple month objective, I would think, to clean up some code and some example data and some descriptive information. But I know Corey and I have kind of been noodling on this for a while, and so thanks for the nudge there. I think we can make that happen. Then when Jackie and I and others compile notes from this meeting and send that out, there will be a link to invite you to the Slack channel. So for any reason you don't get to that invite in time and you're still interested, please ping me again. At this point, we turn it over to Jean Lorbert to talk about his work in Appalachian Forest